Wait a minute. Now can you visualize? Yes. Now it comes to the 1990. Okay. So now we have to again do some adjustment. We have to rotate the operators also. Then it will come, this magnetic needle will come towards the 1990. Okay. So how to adjust the operators? We need to keep this pointer at zero पे point करना है इसको pointer को. It was very sophisticated actually. Little bit actually want more. Now it's fine. Okay. Wait a minute. I think this is much better. Okay. Now when you set it at 0, then again what we will have to do, show normal. Wait a minute, just wait a minute. Let me. Okay. Now is it fine? Any issue?
No, ma'am, no issue.
Okay. So now you can see 0 adjusted, and magnetic needle is of course set at magnetic meridian towards 1990. Fine. So this is the north of magnetic needle and the relaxed towards the south of Earth, and this south is relaxed towards the north of Earth, right? So now it is being set in the magnetic meridian, Earth's magnetic field. Now what we will do, again we need to check the variables, whatever we, okay, एक करके check करते, number of turns of the coil, still it is inactive, so let's wait. Rotate compass, the job is over. Rotate operators, the job is over. Whatever we have to do, show normal. Okay, normal. And then again we can see, we need to do what? Zoom compass. Okay, when you go for the zoom compass, show normal, and then go to the initial setup, right? Connections, and this, and here, one, two, three. It means one is left now. This one. Fine. So your connection is completed now. Okay. Now you can see this is active. So let's do that. Initial setup is over. Insert key of turns are active. So please keep number of turns 15.
Ma'am,
Ma'am, your
voice
voice
is
is not
slight.
coming.
Again, alignment. Can you hear my voice?
Yes.
Fine. Okay. You can see my screen also, right? Okay. And we go through the value again. You can see the variables and result here. So initially we have to go with the initial setup. Uh, but at my end, actually, it is shared, sir.
Sir, it is
Please
sharing.
check it.
Ma'am, it is
Ah,
visible. Yes, ma'am, it is visible.
it's visible, na? Fine. Okay,
Yes,
बच्चों.
ma'am.
Thank you so much. Okay, so when we rotate the operators, rotate कितना करना है बच्चों? इतना करना है कि यहाँ पे 90 आ जाए, है ना? This is the basically the direction of the plane of the coil. Fine. So here we need to rotate compass till 90. So let's do that. It's not 90. Wait. Little bit ऊपर आना चाहिए है. Going little up. One more step. Again one more. New set of. So here you have to basically note down. बच्चों ये हमेशा ध्यान रखना पड़ेगा. When it will be active, kindly note down the number of turns of the coil, radius of the coil, and current also. Current we need to basically make us show normal. And here what we will do again, we will do experimental setup. In this way, like make connection wires लगा देंगे हम. ठीक है? Fine. And this one, and this is the last. Sorry. And okay, fine. Now connection has been made properly. Okay, again we will take the insert key. Let's insert some values here, number of turns. Let's put now 20 turn. Fine, 20 turns लेते हैं. Then we will go with the radius of coil. In the last observation we have chosen 5. So let us put it 6. 6 के लिए कर लेते हैं हम लोग का. Now this is the radius of coil is 6. So please note down all the values, make a table. Okay. Now we have to adjust the rheostat. So you can flow basically same current भी रख सकते हैं. I think we have chosen earlier 0.5. Fine. 0.5 ले लिया. Okay. Now you can see the result. You can note down radius of coil and the current is 0.5 m. Okay, and number of turns are 20. So please note down everything at all and then show the result. So basically it is giving out 0.17 and earlier it was 0.19. पहले 1.19 था reduction factor. Okay, now it is 0.17. But actually, there is no observation table which is available here. But you can make a observation table. Okay. So then you can find out just plugging all the value of putting all the values of like radius of coil, the current, number of turns, then find out the value of reduction factor K. Okay. K हमें पता ही था K क्या था. What was K? K is nothing but defined as 2a. Mu naught is the permeability in free space 4 pi into 10 to the power minus 7. And then you can pH and a the radius or 2a is the diameter, okay, of the coil, and n the number of turn. So you can put all the values here and then try to find out this value. Okay. So again you can go with the same next setup of observations like initial setup. Okay. And then go with the, now you can see whatever we have already set the values, you can note down the deflections also and then find out the values. Okay. So basically here you can change the values and find out the effect of different variables on the experiment, this theoretical formula, and then can see the effect in the experiment. Okay. So here again we can do the same process, just keeping it in this way, 90. Fine. Wait. Let's do one more. थोड़ा सा करना पड़ेगा और एडजस्ट. थिंक सो इट हैज बीन डन. अगेन आप क्या करेंगे, पॉइंटर्स को पुट करेंगे बाय रोटेटिंग द ऑपरेटर्स एट 0 पे पुट करते हैं. राइट. तो लेट्स डू. इट्स कमिंग टू 0 नाउ. ओके. ये 0 पे आ गया. स्टिल सम एडजस्टमेंट इज रिक्वायर्ड. थोड़ा सा एडजस्टमेंट करना पड़ेगा. I think it's fine, huh? Now you can go. Still, some of the keys are inactive, huh? Then we can go with the, to make it active, show normal. Show normal, that means actually, uh, you can see here the compass, show normal. Initial setup, like you can go with the connections पे जा सकते हैं, right? Do the connections here, right? So now this is being connected. Now again click on three line को click करें, and initial setup, show normal, and insert keys. With the help of insert keys, we can keep the number of turns. In the last observation, we have chosen 20. So let's choose 25. Okay. So in 25, actually, now we can go with the reverse current, and this you can see the change. The radius of coil, you can choose the 6, then you can go with the value 7, fine. 7. Okay, now we have to adjust the rheostat. Rheostat को adjust करें. Let's choose 0.5 m, and then we can see the result. Show result. This is 0.16. Okay, so these are some values you are looking after in the terms of like reduction factor. Reduction factor आपको यहाँ पे मिल रहा है देखने को, ठीक है? So which is basically part of like consisting of some current versus reduction factor. Okay, so here when the number of turn was actually 15, so the reduction factor was 0.19, and when it was number of turn of the coil is 20, it was 0.17. Then you can see the change in reduction factor 0.16 when the number of turns are 25, right? We have chosen so far 25, है ना? तो 25 के लिए ये आ गया at the same current. So you can see, even you can reduce the more current, like you can keep it up to 0.25 amp, okay, and can see the result. Let's do that also, and then you can reverse that also and see the result what is coming out 0.16. Fine. So this is the beauty of experiment. Like you can choose the value and then again go with the same value. Fine. So these are actually the things you can do in your experiment, and by adopting you can see the result here, everything at all. Like, but what is the beauty of experiment? Like suppose you are learning something, you can put the value here. So better is to keep all the values in an observation table, like keeping I as a zero point 0.5 amp, or let's say a 0.25 amp. Okay, so you can keep you can see the change in n, actually value n value में क्या change आ रहा है, you can see that. Fine. So here actually you can do one more thing. Once you have the value of I mu naught n and 2a, you can find out b value. Okay, so that can be written as is equal to bh tan theta. Okay, so here you can see the reduction factor is this one, 2a bh over mu naught n. Fine. So this may be actually calculated in case of just by varying some of the values and keeping other values constant, you can have the value. Okay. So here you can see BH is mu naught NK over 2A. So BH can be find out when you have the value of reduction factor K. So when it was K, just keep making the observation table like for A equal to 7 centimeter, radius of coil is 7 centimeter, and the number of turns is suppose 15, and the K value reduction factor it was 0.19. So you can find out the horizontal component of Earth's magnetic field BH. Fine. So when you have this, actually, then you can find out the tan theta value also. Okay, and then you can even you can plot a graph also K versus tan theta. Okay, you can uh, change. You can see the pattern of the graph. We are plotting graph with the K versus tan theta. Okay, this is up to you. It doesn't matter like you have to plot whatever is mentioned in your textbook. Always try to plot a graph in any equation. Like suppose it is not given in or mentioned in the your textbook, but try to plot a graph in equation just by keeping some values constant and varying some input values. Okay, do not copy down. उसको copy down मत करो हमेशा.
मैम मैम डिफ्लेक्शन कैसे पता करेंगे, जैसे कि इक्वल टू 1/10 थीटा,
हाँ
तो
हाँ
थीटा की वैल्यू कैसे यहाँ पे फाइंड होगी?
बेटा रिडक्शन फैक्टर तो हमें मालूम हो गया ना के आई का वैल्यू भी मालूम हो गया. फाइन. So you can find out here tan theta also for that. Okay.
यस
Huh. This is the way actually
Excuse
you
me.
can just wait a minute. When we do the experiment, actually, when you flow the current here, so you can find out the deflections in the pointer. Okay. When we flow the current, so you can see the deflections in the pointer, and then you have the deflection in the pointer when the current flows in one way. So you will find out theta 1 and theta 2 because two pointers, so we will have theta 1 and theta 2. And when you go with the reverse current, so basically you can find out. Just wait a minute. You have asked a very nice question. There are two different ways through which actually we can find out tan theta. One way is to find out tan theta as like by putting the value of I and reduction factor k, we can write it down tan theta equal to we can say this is k upon I something. Okay, but another way we can find out actually tan theta just taking average value of theta. Okay, how to take average value of theta? Just go with the experiment initial setup. Okay, so just try to lined up this. Fine. Still some. No, it's not still. Going a little beside. Wait. It's fine. Huh? And then you can put it actually pointers at 0. 0 पे pointer को set करते हैं. Fine. And then go to the show normal. Zoom compass you can see here. And here go to the show normal. Go for the connection. Connection. Everything is attached. Then go with the initial setup. No, not at all. Show normal. Insert key. Then put the value here. Radius. Let's say 5. And then adjust the rheostat. Let's choose some. No, not at all. It's 0.25. Okay.
Ma'am, number of turn.
Number of turns. Fine. Now you are changing the turns here. Huh? Fine. Okay. So 10, 15. Let's choose some 20, 25 or 30. Fine. In this situation, you can see the
मैम जब नंबर ऑफ टर्न पे कर रही हैं मूव तो
now you can see the change in deflection in the pointer, right?
यस मैम
It was in the same direction, and this
यस
is what in the actually you can measure out theta 1, theta 2 from here. Fine.
ओके मैम
Theta, then theta 3, theta 4. When you reverse current, suppose this is theta 1 and theta 2. And when you click on reverse current, then this is measured as theta 3, theta 4. So now you have 4 thetas. Take average of it by taking sum of theta 1 plus theta 2 plus theta 3 plus theta 4 by 4. This is the average. Okay. Now you can take tan of each theta. Not like no, this theta only. Okay. So you have the value of tan theta and I here. Okay. So you can basically write this value and calculate the reduction factor, which is k equal to I over tan theta. Fine. Even you can verify the result with this also. This is coming 0.09. Fine. तो आप कैलकुलेशन को इससे क्या कर सकते हो वेरीफाई कर सकते हो सो दिस इज योर जॉब लाइक हाउ टू डू इन
मैम
डिफरेंट वेज
मैम
फाइन
हाउ टू exactly show theta in this figure
in this figure actually zoom option is not opening it was opened yesterday I was looking after but it's now not could be seen just wait a minute let me do the another way to see this
मैम इनिशियल सेटअप में क्लिक करने पे आ जाएगा
इनिशियल सेटअप में आ जाएगा फाइन ओके वेट अ मिनट लेट मी डू फाइन when we go for the initial setup then we can do zoom na no not at all it's still not showing initial setup yeah fine it is okay so you can find out actually this one is I think is it 71 and this is 70 so fine
okay ma'am
70 71 hai na? Now you can reverse current then again see the effect now how it is one is at 70 and other 60 this is 60 and
68 मैम
68 68 and 70 so now you have earlier it was 70 71 theta 1 theta 2 and theta 3 theta 4 are 70 and 68 So you can take average and find out tan. So this is up to you. Actually, you can make observation table here. Observation table is not available, but not to worry about that. You can make on your own by keeping number of turns constant, or number of turns like you can vary, and keeping the current same value, है ना? Like 0.25 amp. So you can change the radius of the coil, and then try to find out the result. Okay, like reduction factor K. So once you have the reduction factor K and I value, so you can have the value of tan theta. So no issues. You can compare your values with this
मैम
formula.
मैम एवरेज थीटा लगभग मतलब 70 और 60 के बीच में आएगा, जैसे हम कैलकुलेशन करेंगे तो वहां पे रख देंगे टेन
हाँ,
थीटा की जगह.
right. Suppose it is coming 70. Fine. So
ओके
70, you have to find out the tan of 70. Okay.
ओके ओके.
And I value you have already chosen 0.25 m, and K value actually you may find out in two different ways. This is
Excuse me, ma'am.
yes,
Vandita here.
yes, ma'am.
I is proportional to tan theta, so they can note down the current and the mean deflection, and then they can plot I versus tan theta.
That I have already informed them. So there are so many ways they can see the different pattern of graph by plotting a graph with some input and output values. So there are so many things we can do. Even we can plot a graph between BH and tan theta also. Okay, B equal to BH tan theta. Even
No. In that they have to calculate, but I and tan theta they can directly use.
Wait a minute, ma'am. Here, I'm interrupting you. Sorry. Now, here they can they can plot a graph like reduction factor versus tan theta, or I versus tan theta. This is up to them. They can play with the values, because
K
this is
is
beauty.
constant.
I know that this is a
K is
constant value.
constant.
I know
Yeah.
this is a constant value, but they can play with the values. Just by plugging the number of turns, different values, they can plot. Okay. So this is the beauty of virtual lab. They have to realize how this factor is a constant or variable. How something is constant or variable, they can learn actually by plotting a graph. Okay, in a different ways. So when they go through with the theoretical formulas and then plot, this is not necessary to plot graph always whatever mentioned in only your textbook. Please try to plot a graph in different variables also. Okay, variable or constant. Just see how it is constant, how this is variable. You can actually understand by plotting a graph. Yes, it is giving the constant values. That means it is a constant. So you can have a better understanding with the help of virtual. Okay, because here you can change. You can do the arrangement in different ways, right? So this is actually quite possible only in case of this. Even you can find out the BH value, what Vandita ma'am has suggested yesterday. Like put the value in the theoretical formula yourself, and try to compare the value whatever coming in this result. This will be a better understanding through virtual lab. Otherwise, it will be meaningless, because you need to check whether it is coming the same or not. Suppose some mistake is there, you can do. You can see the result like in your theoretical formula, the value is something different. You can inform even the Amrita Vishwavidyalaya also, like your answer is coming little wrong as compared to us when we do it, and try to mail them also. This facility is already available. You can take a benefit of it. Okay, so these are some important aspects of virtual lab. This is not a complaint. Like you can suggest to someone, like they, if anybody is preparing lab, so you may suggest that. Okay. इवन वंदिता मैम, अगर स्टूडेंट चाहे यहाँ पर अपना हर एक एक्सपेरिमेंट करके, लाइक जितने भी एक्सपेरिमेंट हैं, दे कैन गो थ्रू ईच एंड एवरी एक्सपेरिमेंट, और उसको ट्राई कर सकते हैं, लाइक थ्योरेटिकल फॉर्मूले में वैल्यू रख करके, एंड देन दे कैन इन्फॉर्म देम लाइक वेदर कमिंग
uh, from the keys, from the points where the two opposite points should be connected to coil and.
Yeah, I have already mentioned that. So they can reverse the current, okay, and can see the effect. Yeah, that I have already mentioned, ma'am.
Okay, okay.
Yeah, because one of the
I missed
students
that. I
asked a question actually. One of the students has asked a question about tan theta. So there are two different ways we can measure the tan theta. But what is the role of tangent galvanometer? So basically, the current is flowing through it, and it get magnetized. So you are looking the effect of magnetic field. Studying variation of magnetic field is still in this experiment. So we have to see the variation in magnetic field by measuring out the deflection on the pointer. Okay, so you can find out the average value of theta just taking. We have already done this, ma'am. This initial
नहीं नहीं नहीं, मेरा ये कहने का मतलब था कि आई डोंट नो, आई हैव नॉट डन दिस, बट क्योंकि उसमें कनेक्शन, यू आर स्ट्रेचिंग द वायर्स ना, तो दे शुड नो कि कहाँ से कनेक्ट करना है. दैट्स व्हाट आई मीन.
yeah, actually ma'am, this is made on the top of the.
या वो ऑटोमेटिकली सही जगह पे कनेक्ट हो जाता है.
वो एक्चुअली उसका रीजन क्या है, वो रॉन्ग जाएगा ही नहीं. दिस इज सिमुलेटर, है ना. तो वो but one thing could be done, whatever you are suggesting, we can keep in mind, and when reality lab for the tangent galvanometer, we can do one more thing. It's a then know the single key is active. ये एक दिया जा सकता है. So but we will keep in our mind, like when we go for the preparation of a virtual reality lab on tangent galvanometer, this could be done, no issues. Wrong connections को भी एक बार try करके दे सकते हैं, है ना. So that some alarm will be blown up with the different colors like green, active हो गया. So I will keep remember this thing in the near future, because nowadays we are preparing a virtual reality lab for IIT Kanpur. Professor Kantesh Baroni has suggested 10 experiments on electron microscope, and we also proposed 8 experiments, whatever the gap areas mentioned by AICTE. Okay, so total 8 experiments are there. So we will also we are preparing actually the experiment on virtual reality, and I think last day में हम थोड़ा demonstration रखेंगे as सुमन त्रिपाठी
कहता है कि वो क्या कर सकते हैं, तो हमें उसका solution उन्हें बताना है.
जी.
One of the person has joined, like John Ageto. He is from South Africa.
Can you respond? Which one who is?
John, can you hear?
No. Yes.
Okay, John,
Yes.
you belong to which country? Can you please tell me?
India, Meghalaya.
Okay,
Meghalaya.
Meghalaya. Okay, okay,
Yeah.
fine. Were you able to catch out this entire session? Because I was speaking little bit Hindi and English also. Fine.
No, no, it's okay. Yes, it's fine.
Okay. Okay, okay. So, John, you can perform the experiment with the help of virtual labs, no issues. Fine.
Yes.
I'm hoping for the best, like a student will perform. I am today giving once again the next experiment for the second year students. Please try to do that and make observation table. And I will ask you, I cannot ask you, but I can ask you on the WhatsApp group because tomorrow we will be having session for the third year students fifth semester, right?
Yes.
Okay, so what we can do, we can you people can mention your performance on the WhatsApp group. So it will I will be happy to hear from you, like you are performing the experiment, giving some results. Okay,
Okay, ma'am.
any questions?
Now questionnaire.
No, no, ma'am.
Students
Which year,
Ma'am,
sir?
what is
can
your
ask the
institute
questions.
name? Full name?
My institute is Pranveer Singh Institute of Technology.
Okay.
Yeah, and I'm working here from
It is an engineering institute.
yeah from 2009. I'm working here.
Okay, okay, okay. Thanks.
Any question
I
from
think
participants?
students can refer to their practical book for the table.
Yeah, yeah, definitely, ma'am. Even I think what we can do in the near future, we can cater some category of students just to they can join with us and can perform the experiments as well as they can give some attention to prepare new virtual labs.
Actually, Professor Bandita ma'am, I
Mm-hmm.
would like to tell
Yeah,
you,
yesterday also you
we
were
are
telling that.
we are working on preparing the
Mm-hmm.
manual for virtual lab, है ना? With IIT Kanpur, it is under process. When
Mm-hmm.
my proposal will be taken, तो ये हम अवेलेबल करा देंगे. अभी मैं इस पे काम कर रहा हूँ.
Mm-hmm.
अपर्णा मैडम को भी पता है, वो भी हम लोग इसको
Mm-hmm.
मिलके काम करने वाले हैं.
Uh-huh.
तो मैनुअल इन हार्ड कॉपी अगर अवेलेबल हो जाता है तो
Just like theory, you can include in that.
यस 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 यस. तो अभी वर्चुअली
Yeah, just like
ऑल द
theory,
स्टूडेंट्स आर
after the
नॉट
theory, you
बेनिफिट.
will have
हाँ हाँ.
observation table.
तो हार्ड कॉपी में अगर अवेलेबल हो जाएगा तो दैट विल बी वेरी फ्रूटफुल फॉर द स्टूडेंट्स.
It will be better. Mm-hmm.
आपकी भी हेल्प
Yeah,
उसमें
fine,
चाहिएगी मैम.
fine.
Yeah, yeah, I'm surely willing to that, do that.
प्रोफेसर दिवंगर
Okay,
सपाटे सर
can I
अवेलेबल
leave
हैं.
now?
प्रोफेसर दिवंगर सपाटे सर अवेलेबल हैं. नहीं नहीं.
Uh,
तो सर
I
मैसेज
think he is not available. Uh, sir, I have a class at
यस
12:35.
यस राइट वर्कशॉप फॉर टुडे. देखिए जो नेशनल लेवल का हम लोग डेकोरम लेके चल रहे हैं आईआईटी कानपुर के सानिध्य में. तो डॉक्टर अपर्णा मैडम ने बहुत समय हम लोगों को दिया है और आज इसी थर्ड सेमेस्टर के सेकेंड डे भी उन्होंने बहुत अच्छी तरीके से स्टूडेंट्स को गैल्वेनोमीटर के बारे में बताया. वर्चुअली वे कैसे कंडक्ट करेंगे, सारी क्वेरी भी रेज की हैं और मैं उनका धन्यवाद ज्ञापित करना चाहता हूं. और प्रोफेसर वंदिता मैडम हमारे साथ बराबर बनी हुई हैं. मैं उनका बहुत बड़ा आभारी हूं. अभी मैं उनसे फिजिकली मिला भी नहीं हूं और ये बहुत अच्छी बात है कि वो हमें पे भी एंटरटेन कर रही हैं और गाइड कर रही हैं. तो आईआईटी कानपुर की डॉक्टर सुमन त्रिपाठी मैडम भी हमारे साथ बराबर कोऑपरेशन में हैं. मैं अ, अपने प्राचार्य डॉक्टर श्रद्धा गुप्ता मैडम के आदेश के अनुसार इस वर्कशॉप को कंक्लूड करता हूँ. जी धन्यवाद. अगर किसी का कोई क्वेरी है और कुछ है, मैडम अवेलेबल कम रह पाएंगी, हम लोग इरेज कर सकते हैं. व्हाट्सएप ग्रुप के थ्रू मैडम भी कर सकते हैं. तो आप व्हाट्सएप ग्रुप के थ्रू इस चीज को
सर, हम एक
मेंटेन.
और चीज कहना चाह रहे हैं.
जी जी मैडम, वेलकम प्लीज.
हेलो सर.
जी
बताने वाले हैं कल।
जी
उसके बारे में व्हाट्सएप ग्रुप पे डाल दीजिए, जिससे बच्चे
जी बिल्कुल
थोड़ा सा उनको थ्योरी पता हो जाएगी।
हाँ मैं सर्कुलेट कर देता हूँ।
Actually, ma'am, tomorrow we will perform experiment on wave
बेटर रहेगा।
optics. Tomorrow we will perform.
मतलब 5th सेम के
Yeah,
बच्चे
हाँ
के लिए।
tomorrow we
के
will
लिए
perform experiment on wave optics.
हाँ।
That is interference. So they can read about a little bit interference.
Wave optics.
Yeah, wave optics.
Students are doing, and
Sanjeev sir,
Okay.
I will text you on the WhatsApp group. You can send it to the groups.
Okay.
Till
so
evening, I will.
will circulate it.
students ring you are going to perform which experiment of interference?
Most probably Newton's ring and then diffraction grating.
Newton's ring. Okay. Okay. Yeah. Okay. Thanks.
थैंक यू ऑल। और
Thanks.
फीडबैक व्हाट्सएप ग्रुप के थ्रू हम दे रहे हैं और आप लोग फीडबैक जरूर सबमिट कर दें 2 बजे तक